Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
It's Tien. Tien is from Iowa State University, and their group has been doing a lot of interesting work with large software repositories and how to make them accessible on the internet. And you can go there and get all kinds of data, and he's going to tell you all about it.
All right.
No, there's no mic.
Oh, there's no mic. Okay, good. Okay, good morning, everyone. My name is Tien Nguyen, and I'm from Iowa State University. Today, I would like to talk to you about the Wildcards repository and mining infrastructure that we build at Iowa State University. So this is the joint work with several people at Iowa State University. Hoan Nguyen is my former student, currently the postdoc with me, and my colleague Ridesh Rajan, he's an expert in programming languages, and the rest are the student and me and Ridesh. And I would like to thank NSF for the support for this work. And I hope that throughout the discussion, we can get more user of our infrastructure and make use in the community. So let me first start with the open source repository. So here is the several repository out there that's supporting hosting open source repository. And this is a big wave of knowledge, okay? People can learn a lot about the software development process, what things have been done good, not good, and we can learn from the past and support the futures. And I really don't need to convince you that we need to mine software repository. Yesterday, Tao given an excellent talk on the survey of the area in mining software repository, and this morning, Chark also mentioned again that several interesting research results can be get from mining the repository. So we can learn from the past, see what have been doing well, something that we are not so well, we find anti-pattern, and then guide the current activity in software development and guiding the future development. However, one key problem that we identify in mining software repository is the high-end barrier to entry in big code mining. So any interesting scientific discovery usually have in two parts. The first part is you need to mine the raw data, and then analyze the data to make the scientific discovery. And the mining part is actually a lot of high cost at the beginning for everybody to do any good scientific discovery. And I'll take one simple example in software engineering and mining software repository that people are interested in see how many bug fixes at the noon check, okay? So this is an interesting question because that's supporting the automatic program repair tools and the recommendation tool. If they see that the noon checks are very often in bug fixing, you can recommend it in the future for debugging a program. However, to do this, that's not an easy task. So first you have to identify the host repository that maintaining on the open source project. Those hosts also providing the API, so you need to write the code that conform to the API of the host to mine the project metadata. And then you're ready to write a code for each project. You look at to have the repo or not. If yes, then access the repo, traversing, mining the revision. Make sure the revision is a bug fixing revision, and then download on the source file. For each source file, you need to traverse the code, mining the source code to see if any noon check for bug fixings, and finally output those number or the list of noon check in the program. So this involving a lot of external libraries, some expert on mining, look at different library, different hosts, and different revision control system. I'll take one simplest small piece of this process is mining the source code here for illustration. So we wrote a program in Java with about over 140 lines of code. And that program access to the host repository And the host, for example, SourceForge or GitHub, we need to use a library to access to SourceForge or GitHub. So SVN, Git, those repos return the data in JSON. So the program has to use the JSON library to process the data. And then when you have the file, you need to parse it using Eclipse JDT to traverse the tree and getting on the null check. Okay? And because we want to have the program that's scaled to the large code corpus, we need to use parallelization framework, for example, Hadoop. So we need to write explicit manual parallelization code in the program. And so if you look at the whole big picture, that requires a lot of expertise in different little details before you can actually do something interesting, okay? Before you can actually do any analysis on it. So that's where we think about a solution for that is the domain-specific language that's supporting the large-scale code mining. And this is where our expertise complement to each other, where my collaborator at Iowa State, Ridesh Rajan, is an expert in programming languages, and I'm working on big code mining. So we want to provide the domain-specific language that can easily mine the large-scale code corpus. And our goal in mind is to having a simple language that hide on the details of external library handling the repository mining, access to the repo and get the data, and also hiding on the data parallelization. So the user don't need to know where to access writing explicit code for parallelization at all. And more importantly, we want the program that can scale to million projects and running efficiently get result within minutes or hours rather than days or weeks or months. And here is the architecture of the BOA infrastructure that we have at Iowa State. So first, currently we're having supporting the downloading data to hosting website, which is GitHub and SourceForge. And we replicate it and transform the data and caching the data into and store it in our cluster. And when the user put the query on the website, the query will be sent to our server. Our server will take and compile the query written in BOA, which is the language that we support for mining, and compile it into the Hadoop program, and deploy it in the cluster, execute it, and return the results to the web page. As we're speaking, we are preparing for the release of the next version of BOA, which is running on Eclipse IDE. So actually, if you go to the BOA website, you will see already the link that says Eclipse, BOA for Eclipse IDE, and we will announce officially in the next couple of days. So you can write your program, the BOA program, inside Eclipse with all the syntax highlighting, and you can send the query from Eclipse to our cluster, get result back, and display it and process the data. So that's more user-friendly than the web page that we have in the past 2 years. So this is something that we are working on, and we want to explore the IDE support for that, like debugging, testing later on in our future work. Now let me zoom in the program, because I've been talking about how easy to write this program. So this is the program that traversing the code and look for the null check. Okay, so the program is basically a declarative of input and the output. And here the output is the aggregator, and to visit the program, we can use the visitor design pattern. And if we see any statement, if it's an if statement, we look inside the expression, condition expression, and if it's an equal, not equal, and the right-hand side is a null value, we can send 1 to the aggregator. Okay? And then the aggregator will sum them up and output the result. So the program is small, no external library involved, and you don't need to write details of parallelization. It's automatically converted into Hadoop version in Java and run in our cluster. And more importantly, the most important thing is can scale to large data. So this is our recent data as of September 15. We have almost 8 million projects in GitHub and SourceForge. with 23 million revision, 146 million unique file with 71 billion AST node. So, and then when we run the program, the small program I showed you earlier, on the 69.8 million file with 18 billion AST node, the result come back within 20 minutes. So it's very fast, and then you can analyze that result and then make other analysis and finding in your mining research. So, yeah?
Queries, is it able to support that?
Say it again.
How much load can you handle if everybody in this room started asking queries?
That's a good question. So, but we have the funding support to improve our cluster, and we are in the process of buying and upgrading more computer, and that.
Be supported at Microsoft or at Amazon or something like that.
Yeah, that actually that's something that's also interested to our group, because when we from the research moving on to something infrastructure that support community, that's a lot of engineering initiative that we need to make to make it robust and usable. That's our intention. Yes, we discussed it months ago, and that we all agree in the team that we'll make it available. I think the IDE will be made available.
Microsoft probably would be at least willing to do it for CodeFlex.
Yeah, I should think so. But I mean, we have this Azure HD Insight stuff where you can host Hadoop clusters in the Azure cloud.
Okay.
Yeah, that's a really interesting question, but I can't say yes right now. Come on.
I would love that. You see, yeah. So, okay. So if you wonder how the program works, so basically the cluster, our BOA server, instantiate each BOA program that I wrote earlier for each project, okay, instantiate it, running on it, and every time it see a noon check, it will send one to aggregator, the count aggregator, and the aggregator just, because it's a sum aggregator, it sum on the result and now put the counting upon the noon check. This is very simple concept. And on the automatic parallelization was handled by the compiler, and we're providing several aggregators for sum, mean, top, bottom, set, collection. You can check the programming guide on our website for all built-in function and aggregator that's supporting. And then the BOA cluster will translate the BOA query into Hadoop MapReduce code and run in the cluster. Because we're supporting mining, so we need to have the domain-specific types, and this is where my expertise comes to the picture, where we have to write multiple different domain-specific type for handling different kind of artifact for mining software repository. For example, here you can see code repo is a type, mining software repository type. Get fixing snapshot is something predefined, the user-defined function for domain-specific of mining. We have to write several base type and type for supporting the mining software repository. For example, the project has multiple code repo. Each code repo has multiple revision. Each code revision has multiple file. Each file has AST root, and then having all the abstraction tag tree that you can traverse to over the program. We cannot provide all the domain-specific tasks, we know that. So therefore, we support the user-defined function. So you can define your own function, either in BOA language, such look like this. You declare the function, the return, and the body. Or you can write the user-defined function in Java, and we integrate it into the compiling process in Hadoop, and then you can call that function. For example, the is-fixing snapshot that I explained earlier. This is one of the domain-specific function that check the file type, look at the extension of the file, and see if it match with a certain name. Here's a simple fixing revision that many of us here using in software engineering, mining software repository area. So we look at the commit log and see if the commit log contains the work like fix, error, bugs, or issues, and we consider it a fixing revision. Of course, it's a very shallow, but you can do more interesting with your own defined function for how the revision should be a fixing revision. The most interesting part in BOR is in BOR language is the visitor. Okay, so you can visit the code and do interesting collection in code. The syntax is very simple. You're going to run some statement before, after you see some type, some node type. Okay, and we also can support the wildcards types or list type. For example, if you see T2, T3, T4, then some statement will be executed, or some default behavior for the visitor as well. And the default traversal in BOR is a depth first traversal. So you can see before A, before B, before C, and so on. And at the same time, we also support the custom traversal. So if you don't want the visitor to traverse the children of certain node, you can say stop, don't traverse it. Or you can explicitly traverse certain nodes, so you can define any traversal that you want for your program to collect the interesting feature from different kind of statement in source code. And here's another metadata program that also access the metadata. For example, look at revision, look at the size of the code. For example, this program, simple program, looking at all the Java that can be accessed via SVN and see how many files that change per revision. So that's called churn rate. And so everything is take the function length and then return it to the result. So those are the mining for different kind of things. But for our workshop, I'll prepare a few examples that I will run live to show you that how we can do it for NLSC example. So the first one is the n-gram model. So this is, I'll prepare a field list. So this is the website, by the way. You can ask for the user, and we almost grant user for everyone within a day or so. And you can access and run your program. Here I prepare a few programs that showing for the NL community. So this is the program that compute n-gram in the many projects that we have. Okay, so the idea of that is very simple. You can look at the code here. First, get the snapshot in Java program. Visit the snapshot for each of the snapshots we have. And for each of the nodes we traverse, the first phase is to unparse the program, CNESD node, unparse it, push on the stack. So all of the BOR program, the first phase is the mapping phase. We'll unparse it. So you see here pushed on the token. If you see the for loop, we push for open and recursively call in the initialization and recursively call in condition and update and push on the token there. And we do the same thing for other variable expression, etc. And in the second part of the program, which is the reduce phase, the aggregator will pop the token that we push in the first phase, push it up, and forming the string. In this case, this program I hard-coded for the n-gram with n equal 5. And then we will counting, and output aggregator will output the top 10 most popular n-gram in the corpus. Okay? So that's a very simple program. Let me initiate it and see, change into the mode that we can run. Okay, and I will run it on the small data set so that we can see the result. So any guess what is the most and 5 gram most popular one?
Int I equals 0.
And I equals 0. Okay. We use it a lot in our paper, right? Yeah. To speak. Does it run? Okay, so let me see if the result, I think it's done. Okay, so this is run in a small data set, so you can see the result. I can show you the result right away. So you can see the output right there, or you can download it. Still waiting. I hope the server don't die on me. Okay, here we go. So you're almost correct. So it's equals 0, semicolon, semicolon, plus, plus. And then, semicolon, semicolon, plus, plus, I, closing, or the for loop here, right? So that's, in fact, Charles is right. We speculate that this one is the most popular one. And we use it many times in our paper in Naturalness in source code. We claim that source code repetitive. And this is the evidence, right? The evidence that this for loop occurs quite a lot. And if you look at that, there's also this for loop also interesting. This empty for loop also very popular, but not as popular as the for with I equals 0 or so. Okay, so you can mine that sequence and you can do own analysis on that with your own program later. And we have you with the first part, that mining the data from the source code. All right. I also prepare other tasks that do other thing. All right. So this is the program that we look at the method call. So instead of all the sequence, open parentheses for I, you not interested in that. You might be interested in the sequence of method call. So many of the research in software engineering try to look at the usage pattern. I think we talked about it, the usage pattern in chart talk that looking at API usage pattern. So we want to see what the pattern, the sequence pattern that program look like. For example, the sequence like file input stream, and then instantiation and read and close. So this is one API user pattern example. And here, the programmer doing that, I just need to traverse the snapshot, look for the method call, and chaining them, collecting them. And then when you got the result, you can do frequent mining on that. And let me show you the result. Actually, this runs also very fast. The program runs about 2 minutes or so. But the output very big. So you see 2.87 megabyte. And so here is the list of the methods for each method call in each of the method body. Remember that here I do not keep the interested API. For example, if you like to look at JDK, you can add into the code that the boa code I showed you earlier to filter, keep only the API. Here, on the method call. Maybe some method call now within the project. So, for example, this code, you can see this is more like compiler code. And they have in a lot of translate, set enable, clear, set file description, and those things. But if you write your own code that filter the project specific and keep only the API, you will get the interesting call, get file, for example, get file, get name here, this down to bottom here. And then when you have in the list of method call, you can do frequent item set mining to find out the frequent of method call. So you get the API user patterns from the raw data that we provide. Any questions so far? The other task that I want to show you is actually mining the control flow. So we look at the, it's a little bit longer, but we look at the control flow, what type of control statement in the program that's most popular, okay? And any guess? So let's view the output. Oh, okay, still waiting. This is the cache result. Okay, here. So the here is not actually truly controlled yet. We just look in the SD type, but you can do more finer grain analysis to get the real flow. But you can see here the statement expression, get a method call, and access to variable occurs quite often. I keep only the sequence of 3 elements, but you can extend it further if you want. Or here you have a method declaration. Inside you have a block, and then inside the block you have an expression. So it's also very popular. So you can do other things on top of this to access to more interesting result from our raw data. But we provide the abstraction level that you can get over overcome the simple challenges that hinder the several mining tasks. And currently we have more than 300 users, and you can go to this website asking for user, and you can test and running on many other query involving not just the code. The demo that I give you is about code, but here we also having the metadata that you can mine on. For example, what are the 10 most used programming languages, or project management, so how many projects were created or self-created, and how many projects using certain version control system, or what is the most 5 most used license in those data set, and how many projects use more than 1 license, and many more other interesting. And so please visit the website to have more information. And one thing is the board infrastructure has been selected to be the data set for the mining challenge competition at the Software Engineering Conference called Mining Software Repository 2016. And the deadline is February 19, and that's what we talked in the previous session on the competition. And so MSR conference have been storing the data over the year. Yesterday, Tao listing on the link to the previous MSR from 2006, right? And up to this year. So we have some other ongoing work. So clearly the task of supporting board for Eclipse IDE, we are getting there. However, there's still several other challenging research as well as the engineering effort. For example, building debugging, how to debug for the big data program. Some program can run, hours. So how do we know that when we stop the program and see it's not correct, or testing them? Other efforts involving optimization when you have multiple people connecting and get the query of very similar data. So how can we chain them together and reuse other query and you reuse a component, other query of other people that have been posted on the website or have been sent to the server. And so facilitate the result sharing, collaboration is also challenging. Several software maintenance and program analysis can be done when the program was loaded in IDE as well. So research on program analysis, debugging, testing, IDE support like code completion, for example, for BOA program also very useful. And finally, I would like to say that we have been using the BOA to get the raw data and process some raw data that can be benefit for NLSE community. For example, the work that we published, 13 chart mentioned about it. So we have the annotation on the code. So the n-gram model keep only the lexical, but we want to keep also other annotation, semantic annotation, like what is the data type, or what is the token type, like field access, method call, variables, and all those things. We have the data set that can you can mine the code and the sequence of semantic annotation together with the code as well. We're also having the API usage pattern that we mine using the graph-based statistical language model, which we published this year at ICSI. So we're having on the data that an API usage that I show you, the find new, read, write, but we have it in the graph model, the graph data structure. Other two things that also interesting, the data set that is used for language migration. We've seen in the previous talk, and we were able to mine the data that having two implementation in Java and C# and mapping them, and we have about 80,000 pairs of methods in Java and the corresponding version implementation in C# that you can try out for your migration, for your translation algorithm or model. And last, we have in the corpus that doing the code synthesis. So given the text, we want description of the task. For example, create file, read to the file, write to another file, and then we synthesize the code and put out the API used for that task. And the corpus is from the text and the code, and we mine it from the Stack Overflow and get that pair of code and text correspondingly for the task. So I'm happy to share with others in the audience, and also open for collaboration, and we can talk more in the next few days. And so that concludes my talk, and I'm happy to take questions.
Is the web interface the only way to access those data, or do you have a large tab or archive of those metadata that we can download and perhaps analyze offline?
The website or the Eclipse IDE that you can download the data from. So you mean download?
You have a plugin, but I understand they still talk to your server. But I wonder if you have like a big archive, a tab of the metadata that we can download and analyze offline.
So currently, if you want to get the data, you have to go put the query and go through our server. We don't put the raw data because several other legal issues that we put the raw data and we cannot distribute it, something that we are not own.
So we can only download the query result?
Query result, yes.
Thank you.
Yes, Tao.
Like your infrastructure is very useful for serving as a building block for like curiosity-driven scientific discovery, understanding, exploring this data set for inspiring your new tool or two ideas, right? It seems that, quite some of the work that you have done were actually based on the BOA infrastructure. I'm wondering like how easy it is. Let's say I want to build some useful tool, right, being used by others. And then, because it seems that I have to go in and create a query, I get some result, and I have to integrate it back to my tool. Maybe your IDE integration provides some convenience, but still, I see like, let's say pick any of the papers, say how fast someone could prototype the tool in your paper from the BOA, from the scratch. I don't know.
So I agree that any mining scientific discovery, usually you have to get the data, the raw data, and do analysis on it. And actually the mining part is where I feel that it's most useful, because you don't need to do a lot of engineering to get the data. But the real data analysis, you might have to write what your expertise to. For example, the neural network language model. We are thinking about putting them into as a board infrastructure as well for machine learning. That's one thing that we want to integrate it into Eclipse, but we can only provide something very standard, like Wildcards tools or Mallet library that have been very popularly used. But for your specific needs, that's why we go to the IDE route, because you can still use your own project and own infrastructure that usually you mine with Java or other language that you use, and can still use that. But again, I want to emphasize that the first part is a more hurdle, the barrier that we want to overcome.
In my past MSR studies, I have realized that very often we find some MSR code, we write some MSR code which is indeed buggy. So the metrics we get are just flawed. And so in this case, of course, I can have a bug in my Boa script, so I can check this. But how can I ensure that there is no bug in the Boa infrastructure itself, the compiler? And there can be many problems that could be completely confounding for the metrics I get. So what's your take on this?
Yeah, so you're right. So the bug can happen even in data processing too. So and also in the Boa query as well as in our compiler, for example. But we try to minimize that errors in the converting into Hadoop version of the query, and improving further on the debugging for the Boa task. So you can do the debugging on your Boa query, and you know for sure that, okay, I'll run in a small data set and it's worked fine, and so but or work incorrectly. So you know that you can localize the errors actually in our compiler, for example, and then you can point out to us, and we go and fixing so more in our infrastructure.
So on this point, the point of Prem is key, because if the infrastructure gets open source, the community could go over the Boa infrastructure itself and build a confidence on that it works.
That's right. Yeah.
It would be very useful for the community.
Right. Yeah.
I'm curious about when do you want domain-specific language for data analysis, in this case specific to software data, and when you want a kind of more general language that you would use across domains. So what do you think was specific to the software domain that you really exploited when you were building this domain-specific language?
So your question, you mean which part could be generalized for other than data analysis?
Other types of data,
So the language actually starting from the CISO compiler, which is dealing with the log and Yahoo, and Redash and his student using that, and with our help in identifying the mining software repository types, and we identify and adding more domain-specific time and language into that. So I get the core part is still you can tailor for other. But for example, we are dealing with not just the source code, but other metadata, bug reports, and so we are in the process of extending the data type that's for dealing with issue tracking, comments, and posts, and other things that related to software development.
So trying to get my head around how I would expect to use Boa. So if I wanted to do some new code analysis, and I was like, doing this cycle of debugging and figuring out what my tool even did and how it worked, would I write one analysis up front that kind of pulled down all the data I cared about and then go and do that offline and iterate on my own code? Or do I iterate on my code and call out to your servers every time I run my code? Like, kind of which is the sort of standard?
Either way, it should be good. We support both the ways. So you can write your program integrated every time you need to process the data, you call it out, get the data back, download there, and if it's small enough, like top 10, you can process, or if you get like all the engram, then you need to download and store it in your local and then process it later. But if you just want curious to see top 10, then you can write the program API.
It works fine for me to download a multi-gigabyte output or whatever. It just doesn't cause any problems.
So we support both of the paradigm. Okay. This is one. Yes.
So one of the more interesting things that we should start to think about as a community, especially regarding these extremely large data sets, is that for MSRConf and before, one of the things is the data sets they live on. So a data set that's created lives on for a very long time. But when you start approaching an area where it's data sets as a service, what happens is that the data sets change over time. And when the data sets change over time, that means that the reproducibility of your queries change over time. And that has some fairly significant implications for what we're talking about, as we move this. So I like Boa. I think that it's a great achievement. But when you look at Boa or the GitHub archive, it means that we as a community of research need to be prepared to address the fact that well, I can't go and just clone Boa. I can't just go and clone GitHub archive in the same way. And that means that we have to be a bit perhaps more accepting of results that can't be reproduced in the same way, or find better ways to actually validate some of the results that come out of these. Because the existing methods, it doesn't seem like they'll work in the same way.
Yeah, I think, Patrick, you touched a very good point in this case, is that data change all the time. So GitHub data, yesterday, Cheng, he asked me, if the data is synchronized with the GitHub data, and the answer is no way we can do the synchronize on daily basis. Even the data that they have in GitHub, downloading directly from their website, it takes a lot of time, takes tremendous amount of time. And actually yesterday I discussed with Abram, and he very kindly pointed me to the contact person at GitHub. That something that they willing to share, for example. That's much easier than sending requests and downloading user not our resources. Just download. And if we can, they have already facility to update their data. We just provide a query on top of their data. That would be the ideal case. Yeah, Jane.
You just solve that reproducibility problem though by kind of date.
Yeah. Well, but what it means that we need to be very careful about that, because one of the things is, like, if you add in additional repositories that have data that might have been in that time box.
Yeah.
So that's where you start to need to be very, very careful about it. So it's fine as long as we can make some guarantees, but do we want to make those sorts of guarantees? Because those guarantees say that, if there's existing large-scale projects that then move to, example, GitHub, then do we not include those? Do we only include the data that happens after that point? So GitHub Archive actually does this, because GitHub Archive, it only includes project information from the date that they start emitting events, because it's only events. Yeah. So that you can time slice. But with the way that these other sort of growing archives as a service work, you don't have that same ability. So maybe, I don't know, I guess, so one of the things, Tian, that you guys do is that you have just, individual data sets. And so
right, so we have different snapshots over the time.
That this is the data set that I ran over?
Yeah, actually I tried to find it in...
To create a data set. So let's say that I publish a
paper. You create a data set for you. Yeah, that's a good idea.
So these are the repositories that it's scanned at this point in time.
That would be really good, then you can completely reproduce.
So right now we're providing certain snapshots like 2015, September and December 2015 or so. That's why I tried to find out the button that you can select, okay, I want to reproduce in this data set. So actually the result that I run earlier, the result is a little different. You might run in a larger data set.
Just trying to make things difficult for you.
So maybe let's just take one or two more questions and then draw the session to a close.
So this will be quick. So we already mentioned IPython notebooks or Jupyter, which is the new thing. Are you thinking of doing an integration with this?
Different languages or?
These are the notebook functionalities like IPython notebook, where you kind of integrate code and text into one kind of HTML page that runs on a server. So I think that you might be able.
Yeah, that's a good idea. We should look into that. Yeah, that's a good suggestion. Thank you.
One more question.
Could you have solved the snapshot problem by basically just replaying the commits on Git? I mean, theoretically, you should be able to time travel, right? By just like replaying or undoing.
Replace a commit in there. Yeah, that's something that I think we should look into to get the incremental data updating that way.
So let's thank Tian one more time for everything.
Yeah, thank you, everyone.